All right, so this is a short presentation to help those of you who are migrating to the NOJA Power Device Configuration Manager software, or DCM, and are familiar with NOJA Power CMS. Now, DCM has been launched as part of the Relay 04 upgrade for the NOJA Power RC10 and RC15 Recloser controllers, but it's also compatible with RC20 devices as well. So the Relay 04 is the new protection relay module that is compatible with all NOJA Power RC10s, and it shares exactly the same physical appearance as the retired Relay 01 and Relay 02 modules, except now it has additional processing power and the incorporation of cybersecurity capabilities along with an integrated web server and API. So we have the goal to work towards full cybersecurity compliance for IEEE 1686, and this is part of the platform upgrade in order to achieve that. Now, this presentation is designed to help those of you who are familiar with the CMS software to get up to speed with what DCM needs really quickly. So firstly, a little bit about the Relay 04. It's a major performance upgrade, and the electronics have been modernized to ensure that we've got continued support for our RC10-15 fleets over their design life. And so that added performance allows us to integrate a web server into the Relay 04, meaning that you could use a web browser to also interrogate the device, provided you have the credentials to log into it. It also means that we can sign and certify the firmware and the settings files and communications links so that we can achieve our cybersecurity goals with it. And it provides risk mitigation for attacks such as a zero-day attack, unauthorized settings changes, revocation of access, and unauthorized access to SCADA TCP/IP networks and endpoints. So with this upgrade, we have changed what the interaction is between PC devices or mobile devices and the relay in the field. Because the Relay 04 has a built-in web server, it means that DCM, which is the new device configuration manager, acts somewhat like a browser in that the relay will serve the settings files out of it, meaning the relay now knows what business rules it needs to have. And that's important because then the relay knows what settings are tolerable and which ones aren't. It's also a great advantage because that means for every new version of firmware, since the relay becomes self-describing, it doesn't necessarily mean that you need a new version of DCM, which is fantastic for IT teams who look to standardize on a single software package. Now, it's important to note that the legacy CMS software is not compatible with these new devices. However, there is a version of CMS which allows you to export settings files from CMS into DCM template files to allow you to transfer settings between the two devices with minimal effort. So Device Configuration Manager is a complete overhaul of the way that NOJA Power's settings management systems work. However, it's important to note that none of the protection algorithms underneath the system have changed, so it still remains exactly the same as what was there before. But there are a few key differences between the CMS platform and DCM. Firstly, there is the implementation of the business rules. In previous versions of the relay firmware for RC10 and RC15, the CMS software had to know what the settings parameters were for any particular version of firmware. That meant that every time that a new version of firmware came out, you had to upgrade your CMS in order to be compatible with a field device. In the DCM era, because the Relay 04 has the settings files and the settings ranges stored in the relay, when DCM connects to the device, the relay itself tells DCM what parameters are available. And that means that you don't necessarily need to update your software every time there's a new version of firmware. It also introduces security and feature selection, along with user management and firmware upgrade. It also stores your protection global controls in templates. So it's a case of no more needing to request additional buttons to be pressed on devices in the field once you need to commission it. Instead, you can bake all the globals into your protection settings template and then send it to the file so that when it is loaded into the controller, immediately all the features necessary can be turned on. We've also introduced separate templates and live devices so that we don't have a single log that is filled between two different kinds of files that are used for two different things. We've also introduced direct control of live device settings and template approval workflows to ensure that only approved settings files get loaded into the controllers. And lastly, DCM, because there is a web a web server installed in the relay itself, you are capable of accessing the settings within the relay without even using DCM at all, simply using your browser, provided you have the login credentials to actually log into the relay in the field. So because there are some changes between DCM and CMS in terms of workflows and terminology, we'll take this opportunity to explain the difference in some of the kinds of files that we've dealt with in the past. Firstly, the device file. So in the CMS era, a device file was used for two different jobs. Firstly, as a template, so generated with a random serial number or anything of the protection engineer or SCADA engineer's wish, and then they created those settings before approving them and then exporting them and sending them to a field team to load into the controller. When they went to use it, the field tech, they would have to import the settings, copy it across to a device file for a real device that's connected, and then download it into the controller before doing an upload and then comparing between the two to verify that the settings are in the controller. DCM doesn't do it this way. DCM automates most of the steps in that process. So in DCM, we have what's called a template file and a device file. A template file is a settings configuration template that is not associated with an actual field device yet. So a protection engineer or a SCADA engineer would instantiate a template and create a set of settings, have it checked off and approved. Then that template is issued to the field. When a tech goes to install it into a device, they import the template file, connect to a device, and press load. When that happens, a device file is created, which is not a template, but is instead a historian entry, which shows everything that is configured in the device, along with all the logs and all the previous changes with it. And that is associated with an actual serial number. So that is closer to the device file of CMS, except you cannot directly edit the settings inside a device file. You either edit it directly in the controller, or you modify the template before committing it to the device. The device file is the latest actual state of the device that you see in the field. Moving on to transferring settings, this is also a source of confusion in previous generations between download and upload in CMS, and so in DCM, we've automated most of it. Instead, in DCM, we use a function called load template to device. When you connect it to a device, you select load template and you choose from any of the approved templates and press load. At that point, DCM will effectively copy the settings across to a device and load it into the controller, and then do an upload against it as well, so that you have an offline copy of the latest state of the device. It fully automates that process so that the settings that get committed to the field, you've got a record of what actually happened, but it also removes any of the copy pasting intermediate steps that used to be present in CMS. We also introduced two new terms for a configuration package and a security package. So a configuration package is a combination file which includes the user interface, configuration state, feature selection, the security signature, and the business rules. Whereas the security package is a NOJA power signed and optionally an end user signed package of certificates and keys for a Relay 04 to secure it. This is what allows us to have an HTTPS connection to DCM, to the relay, provided that the security package has been loaded into the relay beforehand. So this is quite a significant departure from the CMS workflow, but it allows us to minimize the steps that it takes in order to get an approved settings file into a control and to have a last known state of play for the relay in the field ready for export and import. Now, the way that we've done this is to introduce three different common ways of looking at the DCM package. In other videos, we'll show each of these individual views, but for here, we're going to give a conceptual overview of what that looks like. On a fresh installation of DCM, you will have no supported packages, a live device dashboard view, a template view, and a historian view. The first thing to do is to add a package to DCM, because this is the way that you can create a template. So if we install a package through the basic user interface, you are now capable of creating templates for this version of package. So once we have that system installed, you can now proceed to instantiate a template where you go to New Template, and you select the package version, the device type, and give it a name. In this case for an RC20, and we hit Create. This will be the first opportunity to see the new feature selection function, where you select which features are visible within the device at the time of configuration. So in this case, we pick a small subset, and then these are the only settings that are available in the template itself in order to modify them for configuration. Now, you can choose to make other settings viewable again. However, if they are active, you can't hide them. So you need to make sure they are deactivated before hiding them if you wish to do so. We then also have 3 new states for a template between draft, in review, and approved, and only approved templates can be pushed into a Recloser controller, and only users with approval rights can approve templates. In small teams, the user that creates the settings file can go through a simple sanity check and convert it to approval state. However, in larger organizations, you may only have rights to create templates, and you need to export the template to get a manager to approve it, to set it to the approved state before it is allowed to be imported and loaded directly into the device. You can see there's an import and export button up in the top right-hand corner here of the dial. So then once you want to load the controller's settings into a controller, we go to the live device dashboard and we connect to the controller. At the point that you connect to it, in the background, the historian view will search for a device file with the matching serial number, and if it doesn't exist, it will create one. This is equivalent to the CMS device file create feature, except when it automatically creates it, it also starts retrieving all the settings and the logs so that you have an up-to-date state of play for that device. So the historian view is basically the same as CMS's device view, except the upload feature is automatic, so you always have the latest state, and you cannot accidentally send a file from the historian view to overwrite what's actually in the controller. Now, to put the template file into the controller, you go from the live device dashboard view and you select load template to controller. One button click and this template of settings files is loaded into the controller, and at the same time the historian view gets a copy, an upload effectively, to use CMS language, which has the current state of play of the device file, what changed, what new settings were, all the different configurations, and that's stored here. Now, you can import and export templates. You can also import and export device files. However, they are for different purposes. Device files gives you an actual state of play of a real device in the field, whereas templates are ones that are generally produced by your protection and SCADA teams and approved with a set of settings that you are going to commit to the field. Now, if you wish to copy a device file, say that you have a device in the field and you want to make another version with exactly the same settings, you can go to the device file in the historian view and select clone to new template. This action will then create a new template file in the draft settings, copying the exact same field settings that it had, moving across into the template view. This means that you can then create more and more templates from field devices if you need to. However, you can also use ones approved templates over and over again. So you can one-click load them into as many RCs as you'd like to, and for every unique RC that you do so, it will create a device file that you have below. Another note is that the templates have a feature enablement setting, so when you make the template, you can enable and disable features. When you disable them, you hide them from the user interface. It makes it much more simple for both your protection teams and your operators to use the software in the field. You can't hide settings that are in use or enabled, so if you wish to hide them, you need to disable them first. You may also choose to re-enable them at a later time, and you can do so through either editing the device through the live device dashboard or by modifying the template itself. You go online with a device from the live status device dashboard, or alternatively by right-clicking on any device in the historian view. This will remember the connection details last used to access a device and will jump your perspective view through to live device dashboard, where effectively you are viewing the relay itself and its settings as if DCM was its own web browser. So a summary of the DCM workflow. Packages are installed into DCM, and the templates are created from the packages or they're cloned out of historical devices. Devices in the historian are automatically made when you connect a Recloser controller, or if there is a matching serial number, it will simply append the data to the matching serial number device file. You interact with a Recloser controller through the live device view, but in the background, the historian view automatically captures the device state in that device file.